Hi dear students, welcome to my class. This is your Pawan sir, lecturer in chemistry. Okay, in this video I am going to discussing about the new chapter, the solutions. Solutions. So this chapter belongs to physical chemistry. This chapter belongs to physical chemistry. So the chapter solution, from this chapter we can expect 7 marks for the final examination. How much marks, ma? 7 marks. So in that 7 marks, two 1 mark questions, two 1 mark questions and one 5 marks questions. So totally 7 marks. So in this the question numbers are in that question paper, question number 1 and question number 2. So next 5 mark question is question number 28. In the 28, A is a problem. This is based on colligative properties problem. And B is a 2 marks question. This is 3 marks question and this is a 2 marks question, like explanation question. So this is about solutions. Okay. So before going to this chapter solutions, first we have to conduct an experiment. So in that experiment we need the two beakers. Okay, I am taking two beakers. So these are the two beakers. So in this beaker I am going to fill the water. I am going to fill water. So 100 ml water, H2O. In this beaker also I am going to fill the water, 100 ml water. So we have two beakers. In this beaker water is filled. Okay, half of the beakers is filled by water. So in this beaker I am going to name it as this is A and this is B. Okay. So for this A beaker, next I am going to add sugar. So add nearly 10 grams of sugar for this beaker A. So stir well. After you getting a mixture of sugar and water mixture. Okay, now this is the first beaker. So in this beaker A we have sugar and water. So before addition, this sugar is in a solid state. Which state, ma? Solid state. So this liquid is, sorry, what this water is liquid in state. Liquid in state, right? But in this beaker B, now we have a 100 ml water. Now in this 100 ml water, next I am going to add 10 ml of oil, like kerosene oil, petrol, diesel, cooking oil, anything you have to add in this beaker B. So in this also you get a mixture of oil and water. Oil and water. You have to stir this beaker and we have a two beakers A and B. So if you observe clearly the beaker A and beaker B, we have two different mixtures. So in this first mixture, so before addition, this is solid state right now. So after addition, this sugar is converted the state liquid state. So after the addition of this sugar to water, this sugar is converted into liquid states. So that's why we call as this is a single phase. Single phase. The single phase means in this before addition, liquids and solids do two different phases. After addition, we get a single phase. One more thing, if you check the taste of this mixture, wherever you check the taste of this mixture inside that beaker, the same taste. That means the concentration of the mixture is same throughout the our whole system in this inside this beaker. Right now. So that's why this is a uniform concentration. Uniform concentration. That means the this one component is completely dissolved in this another component. That means we simply call as homogeneous. Homogeneous. But in beaker B, before going to beaker B, this homogeneous. What is meant by homogeneous? One component is completely dissolved in the other component. So one component is completely dissolved in other component. That means uniform concentration throughout the solution or throughout the system. That means the concentration of the sugar is same whole system. But in beaker B, if after addition of oil to water, we have two different phases. Oil is also in liquid phase and water is also in liquid phase. But after the addition of the oil to this water, we can clearly differentiate the oils and water. So the density of the water is heavy. That's why the water is present at the bottom and oil is floats on the water. So this is the differences. That's why this we call as heterogeneous. Heterogeneous means non-uniform concentration. Non-uniform concentration. Okay. So the beaker A having a homogeneous mixture. In beaker B, this is a heterogeneous mixture. So heterogeneous means one component is cannot completely dissolve other. One component is not dissolved into other. So that's why this is having non-uniform concentration. That's why this is heterogeneous mixture. So one more thing. So this oil and water just in this physical states are changed. That means this sugar solid state. So after addition, this sugar is converted into liquid state. Only phases are changes or states of matter is changes, but there is no chemical reaction occurs in between the sugar and water and also oil and water. That's why we call as these components or these substances we call as non-reacting components. What ma? Non-reacting components. Okay. So from this word homogeneous and non-reacting components. From these two words we can construct a definition for these solutions. So from these two words I am going to construct a definition for this solution. So look here. Solutions. So solution means it is a homogeneous mixture of two or more non-reacting components. This is what solutions. I repeat, dear students, observe carefully. So here homogeneous, we know that homogeneous means uniform concentration. So and non-reacting means only the state is changes, but there is no reaction between the sugar and water and oil and water. So these are the two conditions. If we say anything is solution, we have to follow the two conditions, homogeneous and non-reacting. So solution means it is a homogeneous mixture of two or more non-reacting components. This is what solutions. Or simply we can say this one more simple definition: solute plus solvent. That is a solution. So now you have a doubt. What is meant by this solute and the solvent? Solute means it is a component. It is a component that present in a minimum quantity. That present in a minimum quantity that we call as solute. So the component which present in minimum quantity in a given solution. This is called solute. Okay, so I am telling about this solute right now. From this beaker A, solute and solvent, we have a mixture, water and sugar right now. From these two, sugar and water, which one is solute? So I am taking, this is 10 grams and I am mentioning here 100 ml. So 100 ml is more quantity right now, and this 10 grams is lesser quantity. That's why this 10 grams of sugar I am going to consider it as a solute only in this particular situation. Okay, so next is solvent. Right now. Next, solvent. The same way, the component which present in the maximum quantity in a given solution. Maximum quantity in a given solution, that is a solvent. So I am giving some examples. Okay, C2H5OH, ethyl alcohol. So that is a 10 ml of ethyl alcohol that dissolved in 100 ml of water. So from this, can you identify which one is solute and which one is solvent? So clearly, I am mentioning the quantities 10 ml and 100 ml. Which one is a lesser quantity, Amma? Yes, this ethyl alcohol is a lesser quantity. That's why this is solute. And this one is water is solvent. In the next situation, same I am taking a C2H5OH. This is a 40 ml C2H5OH that dissolved in 60 ml of water. Here 40, 60. When compared to these two, which one is lesser, Amma? 40 ml, right? Now that's why this is solute, and this water is also solvent. Next, 50 ml of ethyl alcohol and 50 ml of water. In this case, both ethyl alcohol is 50 and water is also 50 ml. How can we identify which one is solute and which one is solvent? So anyone you can take as a solute and solvent because of same quantity. That's why you can choose anyone as a solvent, as a solute. This is what types of this solute and solvent. Right now. So next is the very important thing, that is concentration of the solutions. Okay, the concentration. This concentration we will discuss in the next class. Okay, thank you.